Hi everyone. Today, we're learning about recursion, a cool idea in how computers solve problems. Let's get started. So, what is recursion? Before we even touch recursion, let's talk about something we already understand, iteration. Think loops. Think doing something again and again until it's done. Here, we're just printing numbers from 1 to 5. Super straightforward. You can almost imagine a loop going. Print 1, now 2, now 3, until 5. This is iteration. Step by step. You're in full control. You're telling the program, do this 5 times. The program just keeps spinning in this loop until the job is done. But what if we couldn't use a loop? Imagine a programming language that didn't support for, while, or do while, but still expected you to solve the same task. Can we still count from 1 to 5 somehow? Yes, but instead of repeating with a loop, we'll repeat using ourselves. Or, more accurately, using the same function calling itself. Let's rethink the problem like this. To count from 1 to 5, I'll say give me count 5, and then count 5. We'll say give me count 4. And count 4 says the same to count 3 until count 1. Finally, count 1 goes. I'm the last number. I'll print myself and stop here. Then each of them comes back one by one, finishing their job and handing control back. What just happened is called recursion. Recursion is when something calls itself to solve a problem by breaking it into smaller, simpler pieces. It's like splitting a big task into smaller versions of the same task until it's easy to finish. It's like telling a friend, I can't finish this task, but you can. And if not, ask someone else. Until someone finally solves it. And then the answer travels back up the chain. So why even use recursion when iteration is easier? Because some problems are naturally recursive. Their structure just screams, break me down into smaller versions of myself. Soon, we'll look at problems like summing numbers, traversing trees, solving puzzles, and you'll see how recursion makes them elegant and intuitive. Let's see one more example. Imagine you're holding a wooden doll. You open it, and there's another smaller one inside. You open that, another one, and again, until finally, there's a tiny solid doll that doesn't open. With recursion, you think. Take one step up, then figure out how many are left. That tiny, solid doll, the one that doesn't open, that's your base case. Every recursive problem eventually leads to that smallest, most fundamental version. And as you go backwards, each doll closes over the smaller one, just like recursive calls returning. 2 things make it work: a small step, like move up 1, and a stopping point, called the base case, like no steps left. The base case is huge. It's when you stop breaking it down and start solving. So, what happens if there's no base case in recursion? Well, the function never stops calling itself. Each call waits for the next one to finish, but that next one also waits, and so on forever. Each of these is a function waiting on the next one, like a stack of plates. But here's the thing. Your computer has limited memory allocated for function calls. That memory is called the call stack. If this keeps going without a base case to stop it, your call stack just keeps growing and growing until there's no more space left. And then, stack overflow. A base case is like a brake. Without it, recursion is like a car speeding down a hill with no way to stop, and eventually, it crashes. That crash? It's called a stack overflow, and it means your computer ran out of memory for more recursive calls. Now, let's talk about a classic example, a factorial. Take 4 factorial, 4 times 3 times 2 times 1 equals 24. With recursion, it's 4 times 3 factorial, then 3 times 2 factorial, down to 1. Multiply back. 1 times 2 is equal to 2. 2 times 3 is equal to 6. 6 times 4 is equal to 24. Each step waits in memory until you hit 1, then solves back up. Try this. Imagine you have a jar with candies, and you want to know how many there are. With recursion, you think. Take 1 candy out, then figure out how many are left. So it's 1 candy, plus the rest. You repeat until the jar is empty. You've got recursion now.